Sometimes the answer to the quadratic equation is not a real number solution. Sometimes it is an imaginary number. For example, we're going to find the zeros of g of x equals 3x squared minus x plus 8. Again, we are going to identify the quadratic coefficient, the linear coefficient, and the constant. So the quadratic coefficient A is 3, the linear coefficient B is -1, and the constant is 8. And we're going to use the quadratic formula. So x equals negative b, which is -1, positive negative, square root of b squared, so -1 squared, minus 4 times a, which is 3, times c, which is 8, over 2a, which is 3. So then we'll have x equals negative times negative is positive, so positive 1, positive negative, square root of -1 squared is 1, -4 times 3 is -12, and -12 times 8 is -96. And we're going to divide this by 6. So then we'll have x equals 1 positive negative, 1 minus 96 is the square root of 95, square root of -95, I'm sorry, over 6. I cannot simplify the square root of 95, but I know that the square root of -1 is the imaginary number, it's just I. So 1 positive negative, square root of 95, I over 6. And then that will be the answer. What this means is that if you were to graph this equation, 3x squared minus x plus 8, it will never ever cross the x-axis. That's what that means. And sometimes you don't have to solve the whole quadratic formula to know if an equation is going to have, or a function, if it's going to have one solution, two solutions, or no solutions. Sometimes you just have to solve whatever is inside the radicand, whatever is inside the square root. That is called the discriminant. So the discriminant is b squared minus 4ac. Again, this is what goes inside of the radicand. And when this number is less than 0, so that means that it is negative, that means that we will have no real solutions. This means the graph will never ever cross the x-axis. When the value of the discriminant b squared minus 4ac equals 0, that means that there is one solution. That means that the graph is going to be on top of the x-axis. It doesn't matter if it's facing up or upside down. That's irrelevant. What matters is that there is one solution and that the graph is on top of the x-axis. And when the discriminant is greater than 0, then that means that we have two real solutions. Two real solutions. So that means that the graph is going to cross the x-axis twice. So let's go ahead and work on some examples and see each one of these different scenarios. We're going to determine how many solutions each one of these equations have. And we're going to begin with this one. And to use the quadratic formula, we have to write the equations in standard form. So we're going to have to make this equation equal to 0. So I'll add 4 to both sides. And I will end up, let me change the color. And I will end up with x squared minus 4x plus 4 equals 0. And we're going to do the same thing we were doing before. We're going to identify the quadratic coefficient, the linear coefficient, and the constant. So the quadratic coefficient A is 1, the linear coefficient B is -4, and then the constant is 4. So we're going to use the discriminant, which is b squared minus 4ac. So b is -4, so -4 squared minus 4 times a, which is 1, times c, which is 4. Let's see what we get. Negative 4 times negative 4, that's going to be 16. Negative 4 times 1, negative 4. Negative 4 times 4 is negative 16. Negative 16 equals negative 16. And what did we say before about the discriminant being 0? Well, we said that when the discriminant is 0, that means that you will have one solution. And if you were to graph this, then the graph will be on top of the x-axis. I know the graph will be facing up because the value of a is positive. So I don't know exactly where it will be, but I know for a fact that it's going to be facing up. Okay, let's take a look at this other example. Similar scenario, I'm going to move the 2 to this other side. So I'm going to subtract 2 from both sides. So I'll have x squared minus 4x minus 2 equals 0. Again, not a equals 0. Okay, so I'm going to identify the values. So the quadratic coefficient is 1, the linear coefficient is negative 4, and the constant is negative 2. So we're gonna write them on the discriminant, b squared minus 4ac. So b squared is negative 4 squared minus 4 times a, which is 1, times c, which is negative 2. So then we'll have negative 4 times negative 4 is positive 16. Negative 4 times 1, negative 4. Negative 4 times negative 8, positive, no, negative 8. I'm sorry, negative 4 times 1, negative 4. Negative 4 times negative 2 is positive 8. And then 16 plus 8 is 24. 24 is greater than 0, so what that means is that this graph has two solutions. And if you were to graph it, gosh, this is a horrible line. And if you were to graph it, then the graph will cross the x-axis twice. Now, I know that the graph will be facing up because the value of a is positive. I know the y-intercept is negative 2, so I know that it will go through here. And I don't know exactly how it's going to look like because I really haven't found the vertex or the axis of symmetry. All I know is that it is going to cross the x-axis twice and that it is going to be facing up. Let's take a look at this last example. Okay, so we have x squared minus 4x equals negative 8. We're going to do the same, write it in standard form. So I'm going to add 8 to both sides, and that's going to give me x squared minus 4x plus 8 equals 0. So then the value of a is 1, the value of b is negative 4, and the value of c is positive 8. So the discriminant is going to be b squared, so negative 4 squared minus 4 times a, which is 1, times c, which is 8. So negative 4 times negative 4, that is 16. Negative 4 times 1, negative 4, times 8 is going to be negative 32. 16 minus 32 equals negative 16. The value is less than 0. So then that means that there will be no real solutions. So if you were to graph this, and again, we don't know exactly how it's going to look like. I know that the y-intercept is 8. 1, 2, 3, 4, 5, 7, 8. So it will go somewhere around here. I know that it's going to be facing up because the value of a is 1. I'm not going to find the axis of symmetry or the vertex, but let's say that it goes like this. I know that it's never ever going to cross the x-axis. It has a minimum value, so then that means that it has no real solutions. So that's it. See you next class.